Hey guys, here is your middle of the road example to kind of get you through your homework or the problems that you end up trying if you do try them tonight. And this was I think we ended the last video just sort of playing around with this one as an example. Let's actually solve this one. Let's look at this picture and find the area of all the leaves of this picture. Sometimes they'll just ask for one leaf, and obviously you can do the whole thing and just divide by 4, or maybe do like, just one little part of the leaf and then double it to get the full leaf. It kind of just depends on what's easier. Wherever it's easy to get the values that you're going to use, go with the easiest route possible. Okay? So how do you even know that this is, one full loop, 0 to 2 pi? Well, again, remember the little trick. If you go to your y equals, you can sort of trace it as it goes. So I like to use the one like this that looks like a key. Okay, let me zoom in on that a little bit. See that? And then when you watch it go, you can actually see and follow. Okay. So they're still going, it's only 0 to 2 pi. Goes through and stop. And that's it. If it kept going, I'd be a little worried that maybe it would overtrace it. But I think we're in good shape. So, alright, we have our formula, right? Area is from A to B, 1/2 r squared d theta. That's it. It's just the area of a sector adding up an infinite number of sectors. We're accumulating area as the slice goes through. So, as this radius comes through, it's accumulating the area. And occasionally there's 0, right? Because it comes back to the origin, but then it comes right back out. Okay? So the area is going to be from 0 to 2 pi, 1/2 cosine 2 theta squared d theta. And that's approximately straight out of the calculator. So math 9. And we're going to do 1/2 cosine 2 theta squared. I did a parenthesis here, and then I did one more for the squared on the cosine. And that's really it. Comma x, or theta in this case. Again, I'm in polar mode, so theta's coming up. Comma 0, comma 2 pi. And what do you get? And there it is, a little slow. 1.57, I guess 1. Done. That's really it. Now, suppose they wanted just one leaf. Okay, well, obviously you could take the whole thing and divide by 4, right? And that's not such a big deal. And you get whatever it is. But let's just say you wanted to just set up an integral that represented one leaf. That's probably a better question, just so that you get that practice. So let's look and say, all right, how do I get just one of these leaves? How do I know when this graph is at the origin and when it's at the origin again? Okay, so we got to figure that out. So we need to know when is this function, or not function, sorry, when is this graph, when is this curve equal to 0? Well, that's when cosine of 2 theta equals 0. When does cosine 2 theta equal 0? Well, when cosine x equals 0 and x equals 2 theta. So I'm just sort of substituting just in my own mind because I know when cosine is 0. Sometimes it's hard if, do I double, do I divide by 2? I can't always remember. Well, I mean, I can, but I'm just saying you may not. So cosine x equals 0 when x equals, let's see, what's that going to be? Pi over 2 and 3 pi over 2, and then all the multiples thereafter, etc. But let's just assume we're doing 0 to 2 pi. So pi over 2. So if x is pi over 2, then 2 theta equals pi over 2. That means theta equals pi over 4. If 2 theta equals 3 pi over 2, well then theta equals 3 pi over 4. Okay, so it looks like all our pi over 4s are when we're going to hit 0. So let's check that out. Let's calculate the value at pi over 4 and see what happens. There's pi over 4 at 0. How about 2 pi over 4, which is pi over 2? Oh, not that. I'm sorry. 3 pi over 4. Sorry. 3 pi over 4. Okay? And then we get that weird, it's something times 10 to the negative, whatever it is. So it's essentially 0, 0, right? So let's do, okay, so actually that's all we really need. We just need the pi, we needed the pi over 4. Because now that I know it's pi over 4, watch this. If I were to just graph from 0 to pi over 4, watch what happens. Okay, so it started here, and then it came here. Okay, now the next one looks like it was going to come through. So if I just want this first leaf, what I really want to do is I want to start from negative pi over 4 and go to positive pi over 4. If I just want the leaf on this side. Okay, so if I do a window negative pi over 4, see how it's kind of went backwards? So I have negative pi over 4 and then at the positive pi. Oh, and I think this happened in class one time. You see that gap? It's because it rounded it. Let's this is negative pi over 4, and let's go minus 0.1, and let's make this pi over 4 plus 0.1, just so that we get that last little bit included. That should help. Can you see it? Okay. So if I were to integrate this instead, just as an example, for one leaf, I could do negative pi over 4 to pi over 4 and do the exact same equation. And I would expect to get exactly what this was divided by 4, right? So if I quit out, divided by 4, I would expect this. So let me do the integral again. But this time go to negative pi over 4, comma pi over 4. And there you go. We're in good shape. So this is 0.393. Okay, so your picture, I'll make a full picture again. 2 pi. Your picture, right? Get a good picture. Figure out what what you're using. What theta values you're using, and follow the basic formula of just a sector, adding up an infinite number of sectors between one theta and another, and you'll have your area, your polar area. All right, guys, that should be good for the majority of it. I will also make one more video in a little bit that's advanced. And that should help with some of those ones that you have like multiple graphs and you have to go like outside of one but inside the other. It's basically ABC, area between curves, but polarly. Okay, or whatever that is. Okay, let me know if you have any questions. I will talk to you guys later. See ya. Oh, I just gotta move that out of the way.